This is a recast of the 8,000-word piece. David Rumelhart, pioneer of neural networks and AI learning. From AI VIPs. Let's listen in.
Today's article is about David Everett Rumelhart, a pioneer in cognitive psychology and the early development of artificial intelligence. He was born in 1942 and raised in a rural area of South Dakota. His interest in mathematics and science led him to pursue higher education in psychology, and eventually earned his PhD in mathematical psychology from Stanford University in 1967.
His academic career was marked by a deep interest in understanding the processes underlying human cognition, leading him to explore the interface between cognitive science and artificial intelligence. He held prestigious positions at institutions like Stanford University and the University of California, San Diego, UCSD.
His collaborations with colleagues such as James McClelland and Geoffrey Hinton formed the basis for groundbreaking work in neural networks and connectionist models of cognition. Rumelhart has been a key influence in AI and cognitive science because he bridged psychology and computational models.
Rumelhart's work was instrumental in shaping modern cognitive psychology and AI. His development of connectionist models proposed understanding human cognition through distributed, parallel processing, which was a significant departure from the symbolic approaches dominant at the time.
This crucial shift in thinking brought about his work on the parallel distributed processing framework, revolutionizing our understanding of how the brain processes information. Beyond that, his contributions to the development of backpropagation, an algorithm critical to training neural networks, paved the way for advancements in machine learning and deep learning, which are cornerstones of today's AI.
Indeed, and this wasn't just theoretical work. Connectionist models like Rumelhart's have proven immensely practical, serving as foundational elements for breakthroughs in image recognition, language processing, and other AI applications that have vastly transformed modern technology.
But to understand Rumelhart's work, we'd also need to take into account the historical context of AI during his active years. In the 1950s and 1960s, AI was emerging as a distinct field, with researchers advocating for symbolic AI, an approach rooted in logical reasoning and rule-based systems.
These early AI systems followed a top-down methodology aiming to model human intelligence through symbolic representation. They were great for certain tasks, but faced significant limitations when dealing with complex issues like pattern recognition or natural language processing.
That's where Rumelhart stepped in. He proposed connectionism, emphasizing the role of neural networks in mimicking brain-like processes. His work challenged existing paradigms and pointed AI research in a new direction.
In essence, Rumelhart's work highlights a pivotal shift in the AI narrative from symbolic processing to connectionist models. His theories tackled tasks requiring flexibility, generalization, and adaptation, traits essential to human cognition.
One of Rumelhart's most notable contributions was co-authoring the backpropagation algorithm, which became a breakthrough technology enabling more effective training of neural networks. As such, it has been instrumental to advancements in AI's capabilities.
Beyond his work in AI, Rumelhart was also influential during the cognitive revolution in psychology, which replaced behaviorism by focusing on understanding the mental processes underlying perception, memory, learning, and problem-solving.
Rumelhart's contribution to understanding human cognition was rooted in the belief that cognitive functions could be explained through parallel distributed processing, where information is processed simultaneously across a network of simple units, much like neurons in the brain.
Of his most significant contributions to cognitive science and AI was the development of connectionism. This theory posits that mental phenomena emerge from the interactions of numerous simple, interconnected processing units, which operate in parallel and adjust their connections through learning.
Importantly, Rumelhart's connectionist model introduced the concept of distributed processing, where information is not represented in discrete symbols or rules, but as patterns of activation across a network of simple units. These models were inspired by the brain's neural architecture.
In the early 1980s, Rumelhart collaborated with James McClelland and other members of the Parallel Distributed Processing, PDP research group. Together, they published the seminal work Parallel Distributed Processing Explorations in the Microstructure of Cognition in 1986.
This two-volume work laid out the theoretical foundation for how complex mental processes could be modeled using interconnected networks of simple processing units. It introduced key concepts like parallel processing, distributed representation, and learning through adaptation.
Despite his transformative work, Rumelhart's models did face criticism. In the early years of AI, symbolic AI held sway. These systems relied on explicit representations of knowledge through symbols and rules. However, they struggled with complex tasks which Rumelhart's Connectionist models were better suited to handle.
By introducing models that could learn from data, Rumelhart showed how machines could perform tasks traditionally thought to require human-like reasoning. This laid the groundwork for modern neural networks, where machine learning systems can generalize from data to solve a variety of complex tasks without relying on pre-programmed rules.
Rumelhart's influence didn't stop at academia. His theories have found practical applications in a wide range of fields, from natural language processing to image recognition. His work, particularly on neural networks and backpropagation, directly influenced the rise of machine learning.
So many exciting directions in AI trace back to Rumelhart's work. Developments in unsupervised learning, reinforcement learning, and transfer learning all stem from his theories of distributed representation and parallel processing.
Furthermore, modern advancements in making AI models more explainable and interpretable tie back to Rumelhart's legacy. As we continue to integrate AI systems into critical sectors such as healthcare and finance, understanding and explaining their decision-making processes becomes crucial.
In conclusion, Rumelhart's work laid a strong foundation for much of what defines modern AI today. Even though his early work faced several challenges, many of these limitations have been overcome by advances in both hardware and theoretical understanding.
His influence will continue to guide the field as it evolves further. His vision of distributed, parallel systems learning from data remains one of the most powerful frameworks for understanding both human cognition and artificial intelligence.
That's it for today.